Thanks for the banter, and off we'll go. So again, thanks for joining our training today. My name is Rob Lalonde. I'm Secure Labs Chief Commercial Officer. I'm joined today by Harshal Patel, our Head of Scientific Development, and Rob Syme, our Bioinformatics Engineer, one of our many bioinformatics engineers. So before we get going, let's go over a few housekeeping items. All questions should be submitted to the Q&A box, not to the chat box. So we'll go over those at the end, and Rob might get a chance to respond to a few of those along the way as well. We'd love it for you to participate in the Q&A poll at the end. I think we actually have 2 of them. And lastly, we will be sharing the recording online via email. So if people have to drop off or you want to share it with your friends and your family and loved ones, then you can do that too. So before we jump into the group demo, I'd like to give a short introduction about our company and what we do, and then I will turn it over to Harshal to give you the demo. So let's go. Harshal, next slide. And the next slide. Here we are. So Nextflow has been around for about 10 years now. Many of you know it was created by Paulo Di Tommaso. In fact, the product just had its 10th birthday. We had a cake in our Barcelona office for it. But Secure is the commercial organization behind Nextflow. So while it all started with Nextflow, we now have a whole suite of solutions that we're going to talk about and tools, and we're going to discuss and demonstrate these shortly. Our solutions are based on open science solutions, largely in genomics, but increasingly being used more broadly in biology. You have people doing computational chemistry, mass spectrometry, cool imaging applications, and machine learning, and the list continues to grow. Next slide, please, Harshal. So Nextflow is our original product, which many of you know. We're here to show you today the Tower platform. It's an enterprise control plane that leverages at its core open source Nextflow. In addition to the products and services, the products we offer, Secure offers training and support and professional services. We've got well over 100 commercial customers now. We've got thousands of companies using the open source, and we work very closely with the cloud providers to deliver solutions so you can run your pipelines in the cloud as well as on premises. Next slide, please, Harshal. Thank you. Let's take a look at some quick customer use cases. So the first customer slide here shows how Nextflow powered the UK government's SARS-CoV-2 sequencing analysis. This was in the very early days. Nextflow became widely used during the pandemic for pathogenic surveillance, and that work has taken us into a much wider array of public health use cases, things like monkeypox, wastewater detection, bacterial outbreak monitoring, and so on. So this was definitely an exciting project, and the sequencing was happening very close to where the testing was being done, and it just became a very, very efficient process and was a big success. Next slide, please. Here's another example of Nextflow being used in synthetic biology, maybe not an everyday use case that we see, but still very cool. So developing new materials that are biologically based, bioplastics and self-healing polymers and those kinds of things. Next slide. Here's an example of Nextflow in a direct-to-consumer genetic testing. In this case, it's obviously 23andMe, who uses Nextflow to run their imputation pipeline at phenomenal scale on AWS Batch. The figure you see with the blue lines is from a great Medium article that was published by some 23andMe people. You can see the link, I believe, below. And you can see how they're running 10,000 concurrent CPUs churning through this vast amount of 23andMe data. Finally, we have customers like Invitae. Next slide. The clinical end of care. Sorry, my slides are just changing a little slowly, probably a little lag on the internet. So we've got Invitae at the clinical end of care. Again, very, very massive scale, running data from thousands of patients through the Nextflow pipelines. So we have customers from small organizations with one bioinformatician running just a few pipelines, right up to, as you've seen, some of the largest genomic processors in the world. I'm not seeing the next slide as yet. There we are. So Nextflow is not just a workflow language. It's both a domain-specific language and it's an engine for running applications across clouds and clusters. So that differentiates and allows for ultimate portability, reproducibility, and through its open nature allows for sharing and collaboration. Next slide. So the abstraction of the workflow authoring away from the compute environment and really allowed for the growth of the community, in that researchers and scientists can work together on a shared set of pipelines, even though they may be vastly different compute resources. Maybe it's cloud, maybe it's HPC. This also provides flexibility for any given organization to move the analysis to the data, wherever the data may lie. So you can see here the very broad support for HPC schedulers, cloud schedulers. Next slide. I'm going to show you the growth of Nextflow on the next slide. So Nextflow itself has been growing very rapidly. The growth is strongly driven by the community, particularly the NF Core community. We're seeing all kinds of activity around NF Core, and that in turn is driving the Nextflow community. Obviously, we at Secure have a strong interest in supporting and investing and encouraging this effort, both the Nextflow effort and the NF Core effort. And it's hugely useful that users can take these best-in-class NF Core pipelines and run them directly on Tower, perhaps forking them to use them internally, maybe even modifying to address their own specific analytical needs. Next slide, please, Harshal. So just before I get to the demo and hand it back to Harshal, Nextflow Tower, as I mentioned, is a central command post for managing your pipelines. It provides facilities for reducing cloud expenses. We have one of our customers, a case study that was just published a few weeks ago. You can find it on our website. Talks about reducing their cloud costs by 40%. So that's pretty significant, obviously. Automating manual tasks, so being able to drive the running of pipelines as files arrive from a sequencer is significant. Automating all those various tasks that bioinformaticians run so that you can kind of have a 24-hour automated operation if you desire. Secure collaboration between people working in different workspaces, working on different things and not seeing other people's work. Ensuring reproducibility is really important. So you're going to see a lot of elements of data provenance, auditability, compliance, just being able to look at what you're doing with your workflows, monitoring them, seeing how they're versioned, making sure you're running the right version, right containers, right data sets, all those types of things. Tower is very powerful at provisioning as well. So being able to manage your HPC infrastructure is something that Tower abstracts away. So bioinformaticians don't have to become experts in AWS or Google Cloud, but they can focus on, running the pipelines and doing the science. And really all this comes down to boosting productivity and making the bioinformatics organization more productive. So I think that's it wrap for my slides. I'm going to turn it back to Harshal to give you a demo now.
Hello, thank you, Rob. Thank you everyone for attending today. So what I thought I'd do today is something that we haven't done before, in that give you sort of an end-to-end idea of how quickly you can get a Nextflow pipeline up and running on Tower. It's going to be a live demo, so excuse me if anything breaks in between. It's always a very risky thing to do, but I think if it does work, then we'll be celebrating as an extension of the coronation recently. So Nextflow and Nextflow Tower. So Nextflow is the language that you write your pipelines in, so it's being used very commonly across life sciences, other fields that are now sort of being penetrated by Nextflow as well, including things like astronomy and earth sciences and so on. So anything that can be containerized, literally you can run with Nextflow. Nextflow Tower is our licensed product at Secure Labs that allows you to run Nextflow pipelines and gives you a bunch of other features on top of just running them by the command line, for example. And so there are two versions of Nextflow Tower that we have as a company. The first is the hosted version, and a lot of you were probably contacted as a result of being users of the free version of Nextflow Tower. It does have limitations, but it is fully featured. But in terms of concurrent runs and that sort of thing, there are some limitations. There's a pricing page here to give you an idea of what that looks like. And we also have an enterprise version where we give the containers for Nextflow Tower to our customers. They install it in their environment, in which case they have more control over when they update the application, and also in instances where they may want to have a little bit more control for, say, clinical reasons or others, they can install the containers directly within their environment. So what's important to note is that Nextflow Tower is just sort of a pane of glass between where Nextflow runs on your infrastructure. So we at Secura don't have a standard cloud offering or anything like that, where we run the pipelines for you on our infrastructure. Everything happens on your infrastructure. And that's partly why Tower has been so appealing, because our customers have their own infrastructures, whether it's Azure, GCP, Amazon, HPC. They can hook in Tower directly into their compute environment. So everything happens on their compute and on their storage. You negotiate your discounts with your cloud provider directly with your cloud provider or with your HPC provider, and Nextflow and Nextflow Tower are orchestrated directly wherever you want things to be run. So I'm just going to quickly sign in here. I'm going to sign in with my GitHub credentials. So this is tower.nf, which is our hosted version of Tower Cloud. And so when I log in, I can see that my user account straight away. But for most of you, when you sign in and create a free account, you'll see this community showcase workspace. And here, what we've done is we've uploaded a number of NF Core pipelines. For those of you that don't know what NF Core is, it's a community that we've created where we develop best practice Nextflow pipelines. And NF Core has evolved to become much more than that now. We've got almost 6,000 members on our Slack workspace, and we've got hundreds of thousands of contributors now over the course of the few years that we've been around. So it's growing from strength to strength, and it's really sort of a community effort where we try to be as inclusive as possible to impose best practices and standardization when it comes to writing Nextflow pipelines. And so we have 70-ish Nextflow pipelines on NF Core. Some of them are added to this community showcase by default, where you can go away and run these. There's $100 of free credits here available to you to go away and test these pipelines for yourselves. But what I'm going to do is I'm going to try and start from scratch. If you logged in as a new user, how can you go about creating an environment in which to run an Nextflow pipeline? So the first thing I'm going to do is I'm going to click on my profile, and I'm going to look at what my organizations are. So I'm part of a number of organizations here because I'm a bit of a dinosaur now at Secura Labs, and so I've accumulated these by osmosis. And so the first thing I'm going to do is add an organization, a brand new organization where I can control and add other workspaces and users and that sort of thing. So I'm going to call this Tower Cloud Demo. You can add a description as well. I'm going to call this Tower Cloud Demo. You can add a description as well. So organization, oops. Organization to demo Tower Cloud usage. Secura Labs, HQ, London. And then I'm just going to paste in the URL for Secura Labs here and upload a logo for Secura there. So now what I've done is I've created an organization. Now within an organization, you can have what we call workspaces. A workspace is an isolated environment for you to have different sets of pipelines, different users, different compute environments. And that way you can sort of segregate who runs what between these different workspaces. So you may have one workspace for your oncology department, you may have another one for your pathology department, and so on. Or alternatively, if you want just to keep it simple, you may have a dev workspace and a production workspace where you do all of your development type stuff in your dev workspace with more experienced users potentially, and your production workspace is for those that maybe less experienced and just want to use the UI. And so I'm going to add a new workspace to this new organization, and I'm going to call it May Webinar. I'm going to call the name the same. And I'm going to say that it's a workspace to demo Tower Cloud usage. Right. And I'm going to create that. Right. So now I've got a workspace. Now within this workspace, you've got a sort of a nav bar at the top there that allows you to add pipelines here, which I'll do in a second. You can do all sorts of other things and get information about what you're doing in this one particular workspace. But before I do that, in my new organization, I want to add a team. So what I'll do is I'll add a team called Webinar Folks. And so this just means I'm adding others to help me either get Tower up and running, or just to have others to come in to launch these pipelines. So I'm just going to add a sunglasses emoji like that, and then what I'm going to do is edit this team, and I'm going to add Rob to this team. Right, so now Rob, I've added a team to my organization. Rob is now part of that team. I'm going to go back to my workspace that I've just created, go to the participants tab and add the team that I created here. You can also add individuals if you like. You don't necessarily have to go via the team route. The team route is just nice because you manage it in one location, but you can even add participants. So Isha, who's also in our team, I can add a note that you can have different permissions for these different users. So this way it allows you to isolate who can do what in this application. The licensing is also slightly different for different sets of users, but launchers and viewers typically are what we call launchpad users, and owner up to maintain are what we call power users. And the power users tend to have more permissions to do things within the application. Right. So now I've added some users to my newly created workspace. What I need to do now is to add some credentials, because I want to run a pipeline. I need to run this pipeline somewhere. In this case, I'm going to use AWS Batch as an example, and I'm going to use the NF4 or an AC pipeline to get it running. So what I need to do is add some credentials. Now, I don't want to give you my life secret, so I may have to stop sharing for a second, just whilst I add these in. But in theory, it's just 3 keys that I add in. So just give me 1 second. Let me stop sharing and add this in. All right, where's the Okay, so what I've done now is I've added 2 sets of credentials here. I've added my AWS credentials to access my AWS compute and my storage. You can get this from the console. There's some permissions that you need to give your AWS account in order for Tower to be connected to it, to your storage and compute. As always, we're on hand to help with that. If you have any issues, and we can help customers and that sort of stuff with that. If you have any other issues setting this sort of stuff up for your own, we've got a Tower Community Help Slack channel on the Nextflow Slack workspace as well, where you can get help for this sort of stuff. But overall, it's relatively simple rather than running and configuring all of this via the command line. You give Tower some permissions, and once you've done that, you can get these keys from your AWS account. And now you can start spinning up these compute environments on the fly. So now I've added some credentials, as I said, for AWS and for Docker. What I want to do now is add a compute environment. So the compute environment is where you will run your Nextflow pipeline. So I'm going to call it Nextflow compute environment. And I'm going to select AWS Batch. The credentials that I've just added are selected here. I'm going to pick EU West 1, which is Ireland, and then a work directory. So the work directory is where all of the intermediate files will be stored when Nextflow is running. So this is the same whether you run on HPC, on your laptop, or in the cloud. Nextflow needs to have an intermediate directory where it stores all of the intermediate files. And this is also very important for the caching behavior in Nextflow and typically the way that it works. And so we set the work directory as just the root of the bucket, which is absolutely fine. And what I'm also going to do is enable some of the cool sort of storage options that we've added recently that allow you to, in essence, in the cloud, it allows you to emulate shared file systems in the cloud to some extent, because what you're doing, rather than copying data into containers when you run these pipelines, with the use of Fusion version 2 and Wave, what you're doing is you're mounting buckets into containers directly. So it really helps with moving data around the cloud, which can be a big limitation with some of these APIs that the cloud vendors have. You hit API limits and pipelines start failing, which isn't nice. And so we've added this to sort of overcome that and make things a lot more efficient. And we're building on top of this to do other really cool things like auto deleting intermediate files and that sort of stuff down the road. So there'll be some good announcements, I suspect, at the Barcelona summit in October. Right, so what have I done? I've given it a name, I've said which region, the bucket. I've just flicked a few switches here to say I want to use Fusion and NVMEs. I'm using spot instances here to save on cost. I'll say I want 500 CPUs in total in this particular compute environment. And then what I'm going to do lastly is just add some instance types. And so what this is doing is, oops, C6 ID. What this is saying is when you launch pipelines using this compute environment, use these specific instance types, and these specific instance types have NVMe disks on board. And in fact, these are the instance types that we used in the blog that we published recently, which Rob can maybe put in the chat, which shows how we benchmark Fusion and costs with the RNA-seq pipeline. So what I'm now saying is, when you're using these NVMe disks, use these particular instance types on AWS that come with these NVMe disks attached, that speed up some of these IO operations and really help with bringing costs down. Okay, so now I'm going to add this compute environment. This will take a second or two to spin up. In the meantime, what I'm going to do, whenever we add a new compute environment, by default, we want to test that it's working. And the best way to do that is to have a really simple pipeline, which is just literally testing that Nextflow, and everything can talk to your storage and your compute as and when it's needed. So I'm going to, is that compute environment created? It's just going to take a second to create. Right, it's ready now. So I'm going to add a pipeline, call this hello world, and hello world test pipeline. You can add labels and that sort of thing, which can help you filter and search for runs later on in the runs page. I'll show you that later on. So for now, I want to add a pipeline called Nextflow IO.hello. And this is just literally like a ping type pipeline where it's just checking that Nextflow and to have access to all the correct infrastructure and in your account. And so here, it's a very simple setup. I'm just adding a pipeline that says hello world. You can even give it a label if you like. And add. Right, so now I want to launch this pipeline against this compute environment that I just created to make sure it's working. And so I don't need to change anything here. All of the defaults are fine. And I just click launch. This will take a second or two to fire up whilst the virtual machines are being provisioned on the cloud side. But essentially, when this pipeline starts running and is finished, then we know that this compute environment is working. And it's always a good idea to check that rather than trusting that I'm doing all the right things. Okay, so in the meantime, what I'll do is I'll add another pipeline, which is the NF Core RNA-seq pipeline. For those of you, again, that don't know about NF Core, we've got a website with tons of information. There's sort of 70 odd pipelines. Some are sort of gold standard Nextflow pipelines that we've been developing for a number of years now. And we've really tried to create a nice ecosystem to develop and write Nextflow pipelines. And so if you look at the RNA-seq pipeline, for example, there's full-size tests and results from that available on the website, as well as extensive usage documentation, parameter docs, output docs, and so on, available directly from the website. But again, going back to standardization, if we now look at another pipeline, it looks exactly the same. And so this is how we're trying to have standard locations for documentation and other things, CI/CD, just to make it much easier to make things scalable on NF Core in general. Right, going back to the RNA-seq pipeline, there's a really fancy tube map as well. Right, so the NF Core RNA-seq pipeline, I want to add that to my workspace as well. So I'm just going to say test Core RNA-seq pipeline. I'll give it its own label to say I'm going to be using a test profile when I run it. Every NF Core pipeline comes with a test profile that allows you to test that it's working before you run it on your data. There's documentation here in the README about using the test profile to run. It just makes it a lot easier to test it on very tiny data that is platform independent, rather than running on big, potentially complex data and realizing the pipeline's failing down the line because you can't pull containers or something else is going on. So it's really nice to always use this test profile to run, and also it finishes in a decent amount of time. It may not finish in time for the demo, but we'll see how far we get. Okay, so now I've picked the URL. Everything in Nextflow works via some sort of version control Git repository. And so here I've just selected the pipeline I want to launch, and I want to use the latest version. And I want to use the test profile, as I mentioned earlier. And so this is actually configured in the pipeline, which is why it's selectable here. And that's really it. So I've just given it a name, optional labels, said where I'd like to run it, and which pipeline I'd like to run. Now I add this pipeline. Let's go back and check whether this is kicked off. Okay, it's still warming up. So in the meantime, what I'll do is I'll add a data set. Now, a data set is our notion of some sort of structured data. And so in this case, it would be a sample sheet. So the NF-Core RNA-seq pipeline takes a sample sheet as input. But most of NF-Core is standardized on using sample sheets as input because it makes things a lot more flexible when you're running pipelines in general, because you can have additional metadata and other stuff included within these sample sheets. And so an example of a data set, in fact, is just a sample sheet. And so if we go to the RNA-seq pipeline, the GitHub repo where all the magic happens. So we have this test profile here on GitHub that is essentially using this input sample sheet for all of this, the tiny CI/CD testing we're doing. So if I just come out of there and I reconstruct that path to get to the sample sheet that I want, this is what it looks like. So what I'm going to do is download this to my desktop. And I'm going to add a data set. Let's say NF-Core RNA-seq test samples. NF-Core RNA-seq profile test sample sheet. Upload that here directly via drag and drop. Say the first row is a header. And now I've got some sort of input that I can put through my pipeline. So this is really nice because it makes it a lot more interactive to upload data to trigger these pipelines as well. You could, of course, trigger the pipelines by pointing to a path, like an S3 path or a local path if you're using HPC to where the samples exist. But in this way, you can sort of make things a bit more interactive. And also there's a bit of provenance here when you run this pipeline. So, okay, I'm going to add my data set. This pipeline has now started running. Hopefully it should finish. I just want to see that one process is completing, and then maybe we can carry on. Okay, let's be. Let's live life on the edge. Okay, so let's trigger this pipeline anyway. If you click on the pipeline, you can get all the details and that sort of stuff associated with this pipeline. You see the labels that I added. You see the default compute environment. You can, of course, also change this up to run on completely different compute environments. So an example of this, definitely not within the scope of this demo, is that you can also configure workspaces like this, where you have pipelines that run on completely different compute environments. Like here, for example, I've got AWS, HPC, Google, as well as Azure in the same in the same workspace. And I can trigger these pipelines on any one of those compute environments. And that's owing partly to the testament of Nextflow, and also now Tower is following in sort of the same vein. So now I'm going to go back to our workspace that we've created. Hopefully there's some progress. There isn't. Okay, let's trigger RNA-seq anyway. So I'm going to launch this pipeline, which is the NF-Core RNA-seq. So you just click on launch from the launchpad. And did the test config get applied? Did. So what I'm going to do is select that data set that we just added, which is now selectable. And I need to select some sort of output directory. And so what I'm going to do is select an output directory, which is an S3 path, because obviously I'm running in an AWS environment, and I want to also publish the results of this pipeline to an S3 bucket that is pre-configured with this compute environment, for example, and has permissions to access. And so here, what I'm going to do is just set the input as the sample sheet and the output directory to where I want the data to be published. So it's really sort of as simple as that. I mean, you can obviously, there's tons of other options you can configure when you run the pipeline. We can see that the hello world finished successfully, which means my compute environment is working. This will now take a second or two to warm up, and eventually it will fire off and start running all of the tasks in this pipeline. But you can configure these pipelines to have default options. For example, if I go and edit that pipeline I just added, you can have parameters here that you set by default. So when users come to launch this pipeline, they're always using the same parameters. And then that way you can standardize how you are doing things internally within your organization. So for example, genome reference files and that sort of thing that you may be trying to use consistently, you can standardize them here and add labels so users can come in and find those. So for example, if I do a label yeast here, and we've only got 2 pipelines, but just to show you, I'll only then see this RNA-seq pipeline. So you can then use this to filter down how you're seeing these pipelines. Okay, so now what have I done? I've added an organization, I've added a workspace, I've added participants to this workspace. So on that note, Rob, if you can just trigger a run of RNA-seq for me, that would be awesome. Just to show you how easy it is to now to collaborate and run these pipelines in real time. I added Rob right at the beginning. So he should now have access to this workspace. He's got access to the compute that I've set up, so he doesn't have to worry about any of this. He just has to run this pipeline on this compute environment. So when we refresh in a bit, we'll see an entry here from Rob having submitted a pipeline. Okay, so that's us running the pipelines now. And this pipeline has now started running. There we go, started submitting runs. Just to show you quickly what a finished product looks like in the meantime. So if we go to the Secure Lab showcase, and I'll look for RNA-seq. So when the pipeline finishes, this is just for the test profile again. There's tons of information here about how the pipeline ran. So the parameters, or the command you used, all of the parameters you would have used, the resolve configuration when you ran the pipeline, the data set that you would have used for provenance, the full execution log as well. So when you run this pipeline and you say, for example, run it by the command line, that's exactly what this output log would look like. You can even download the Nextflow log files directly from the UI. There's also reports functionality here as well that allows you to view certain files, which you can define in the pipeline. So if we go back to the RNA-seq pipeline, there's this tower.yaml file in the root of this repository. Now, this will work with any Nextflow pipeline you want to run on Tower. But what I've done essentially here is just created a YAML file that points to particular files that may be important to QC the data when the pipeline finishes. And so here, our DSeq sort of PCA plots, multi-QC report, some gene counts and other stuff. We're also adding a full-on data explorer functionality, hopefully in the next month or two, that allows you to browse your buckets directly from within Tower as well. But what this allows you to do is essentially QC your data directly here. You can download the report, you can open it in a new tab, and this means that you don't have to go away and access an S3 bucket, or your users don't have to anyway. They can access these results directly from within Tower. There's also task information and other stuff about how your pipeline ran, the resources it used. We've got an optimization feature that attempts to predict based on previous executions of your pipeline what you should be using. And the reason for that is because Tower's got, at the back end, Tower's got it's got a database. And so what it does is at the task level, it stores how much you requested when you ran the pipeline. Now, because it knows how much you requested from the pipeline and then what you actually used when you ran the pipeline, if we look at this task information here, you get the full command that was used for this one task, all of the information about it, the work directory, how long it took, the containers that were used, the resources requested from your pipeline, the instances that were provisioned in the cloud, as well as then what you eventually ended up using As a result of that, we've got this cool optimization feature that attempts to use machine learning to predict, based on previous executions of your pipeline, what you should be using when you rerun the pipeline. And this now becomes very important when you want to have cost savings and run your pipeline more efficiently, especially in the cloud, where you can now start squeezing more tasks into the same virtual machines. And you can also save time as well, because these pipelines finish a lot quicker. And these sorts of optimizations also apply to HPC environments, because ultimately on a HPC environment, you want to be as efficiently as possible when you utilize the nodes on your cluster. And the more conservative and accurate you are with your requests, the better it is in terms of the way that you utilize your cluster. Okay, so that's an example of that. Let's spin back to our newly created workspace. And here we go. So Rob's just triggered a pipeline now as well. The one that I triggered is now sort of ripping through all the different tasks and should hopefully complete soon, at which point I'll have my reports at the end. And Rob's is just triggered off now as well. You can also resume runs. So if I want to relaunch the same pipeline, you can relaunch the pipeline directly from the user interface here. And so that means, you can then benefit from Nextflow's native caching ability to then allow you to rerun the same pipeline. Say, for example, you need to tweak a bit of config option or parameter, you can tweak it directly from here. Everything that would have been run up until the point of failure and was successful won't be rerun, which is one of the strengths of Nextflow. Everything from the point of failure on downwards will be rerun. And again, this is sort of a time and a cost saving exercise that makes it much more efficient to run these pipelines in any environment. Okay, so what these are triggering on. Another thing I wanted to show you is, now that I've run this via the user interface, we also have tons of automation in place as well that allow you to really automate the way that you run these pipelines. And so we've got a command line interface called the Nextflow Tower CLI. We've also got an API as well, which is fully documented here and available for you to leverage your own automation. In fact, the backend container of Tower communicates with the front end of Tower all via API calls. And so you can leverage that for your own automation. And in fact, the CLI is also making API calls behind the scenes, but it's just a much nicer, simpler interface. And so what I want to do is now show you how we can do exactly the same thing, but via command line. So I've got a simple script here that is essentially, hopefully you guys can see my VS Code browser. I shout if you can't. But we've got a simple bash script here that allows us to automate some of this and plug in directly to Tower to launch these pipeline from the command line. So here, our Tower workspace was Tower Cloud Demo, May webinar. Okay, that looks good. What was our pipeline called? NF Core RNA-seq. So that looks good. And so essentially what all I need to do, or should need to do, with everything crossed, is run this bash script from the command line. Oops. There we go, Tower Cloud Demo, May webinar. Oh, wrong variable name, classic. Okay, there we go. Let's try again. Voila. So now this pipeline has exactly the same pipeline that I added to the launchpad, this RNA-seq one, has now been triggered via the command line, where I've just, instead of overriding the output directory via the user interface, I've just overridden it via a command line option here that runs this via the params file. And so what should happen now is we should have a fourth pipeline that has now been triggered via the command line. You can also do exactly the same thing via using the full URL to the pipeline as well. So in theory, let's try this. So now, rather than using the pipeline that I've added from rather than using the pipeline that I added from the Launchpad, I'm running the pipeline from the source repository. I think it might complain about a revision if I'm not wrong. No, I need to specify the compute environment. So the reason that I got that error is because when you add a pipeline to the Launchpad, everything, as I showed you before, is pre-configured. So the compute environment and all of the other settings are already pre-configured with this particular pipeline, which means that we need to, when we run from source, we need to specify where we'd like to run this pipeline. So if we look at the help for this, what is it? Is it compute and let's try now, and I think it should say it wants a revision. Oh, typo. Okay, so by default it will use master, but now I should have 4 pipelines or 5, is it now in total? Yeah, so now this is the one that I've triggered directly from source. Okay, I won't go on much longer. I'm going to hand it over to Rob in a second to just finish off. But hopefully I've demonstrated how within sort of half an hour, I've created a brand new organization with a workspace, added some team members to this organization, hooked in some compute that I have on AWS Batch, tested that compute environment is working with a simple pipeline, and then triggered a test of an NF core pipeline. In this case, it was the RNA-seq pipeline. I've also, as a result of adding other users to this workspace, have allowed them to come in and trigger this pipeline directly for themselves on a compute environment, which they may not necessarily always know the ins and outs of. But as long as you know what input you want, for example, via a data set, and where you want to publish your results, in theory, if you've pre-configured everything up correctly, you can use this sort of automation to do that. There are some cool things on the horizon that we'll be adding, like, as I said, the ability to browse buckets, also the optimization type stuff that I mentioned to you, which will make it much easier to and much more efficient to run these pipelines on these different infrastructures in terms of costs and time. We also have a resource labels functionality already live, which allows you to tag resources you create in the cloud. And that way you can get better estimates of costings and that sort of stuff when you're running these pipelines within an organization to see who's running what and how for budgeting and finance purposes. But otherwise, watch this space, and thank you very much for joining. And I'm going to now go back to the presentation and hand it back over to Rob.
Thanks, Harshal. Appreciate that. That was a great demo. Hopefully you folks enjoyed it. I think that's obviously that's Tower Cloud, and some of you have already tried it out. For those of you who haven't or want to give it another go, feel free to test it out at tower.nf. And if you have any problems, reach out and we'd be happy to help you. So now let's jump in and address some of your questions. Just going to look quickly at the Q&A here. So Joshua Davies asks, is there a way to automate the generation of the pipeline tube map diagram?
The amount of times we hear this, and the amount of times I would love to say yes, but yeah, I guess the simple answer is no. So that whole tube map diagram became infamous as a result of actually James and Sandra, I believe, from, where are they? Max Planck in Germany. And they created it for the ancient DNA analysis pipeline called eager. And since then, it's sort of become a cult type thing on NF Core where everyone wants one. What we do have is some documentation, if I can get out of this screen. What we do have on the NF Core website are all of the different components that you can use to create it. So where are we? Graphic design guidelines. So here, there's various things here that you can use. Am I still showing my screen? I am. Yep, for some reason, the NF Core website isn't loading. Oh, there we go. But yeah, so all of the ones that are currently in existence in these various different pipelines are all sort of displayed here. And there are some semicons and that sort of stuff, and other things. And there's also a bite-sized talk, I believe, as well, where James, what's it called? Here we go. Where's Zandra? In fact,
Satish's already put it in the chat. Thanks. Satish.
Beautiful. Okay, yeah, there we go. So there's lots of documentation, but nothing automatic, unfortunately.
Well, a small caveat on that is that while the tube maps are beautiful and are not automatable, Nextflow does provide some functions for generating graphs of data of the workflow. I'm just going to pop a link to the documentation, and those can be generated in dot or mermaid format. And if you're looking for a very automated way, even if it's not quite as pretty as the hand-done tube maps, those mermaid and DAG visualization docs should get you where you need to go.
Great. Next question from David. Is there a way to connect tower.nf to our internal Slurm cluster? It is better to have a local instance of NF Tower inside my organization.
Yeah, absolutely. So what I didn't show you is, well, I kind of alluded to it when I showed you the showcase workspace, but here, if we go back to the showcase, we have all sorts of different compute environments. So we have all the different cloud providers. We've got one environment with GPUs as well, which we were testing for Protein Fold on NF Core. But there's also HPC hooked in here as well. So Slurm is probably one of the most commonly used scheduling systems, or the ones that we tend to see from our customers as well. And so, yeah, absolutely, you can hook Tower up to run on there.
Great. And then just as far as is it better to have a local instance of Tower inside your organization, you can run to your local instance of Slurm from Tower Cloud if you want. There is an agent required probably to get through the firewalls, but generally speaking, our customers that are running local HPC are running Tower Enterprise and having that run inside their own environment, not using Tower Cloud. So next question from David. I've already tried Nextflow Tower during a demo. I'm curious why your launch option is completely different than your edit option. In the demo, I had these too many were rather similar. The only last two buttons different, launch or update respectively.
I think perhaps this is a question about why when you launch a pipeline, you get the nice UI for inputs. The Nextflow schema.
I see. Okay, so when you click on this, is that correct?
That is different to editing a pipeline.
Okay. So when you edit a pipeline like this, what you're doing is you are setting your pipeline up essentially to run and can pre-configure everything in terms of how you want to run that pipeline on Tower. And so here, what you're saying is, I want to give it a name, a description, where I'd like to run it by default, as well as which pipeline to run and the default revision for this particular version of the pipeline. And then you can also pre-configure certain things like pipeline parameters. So for example, if I want to set out there as an option here and out hard code it as an S3 path, I can do that here. Or if I want to do the same for a genome reference, I can never get this caps right. If you want to set it to a genome reference and then maybe say, okay, instead of yeast, this is now human. What you can do is you can pre-configure how this pipeline will be run by default by users that come and click on this pipeline. I won't update it here, but the difference with this field is that when you launch it, this is showing you how all of the parameters you can set to run this pipeline. So the first bit when you edit the pipeline is the compute, how you'd like to run it, the version of the pipeline. This form shows you simply which parameters you'd like to edit for that version of the pipeline when you launch it. And so actually this schema is coming from the pipeline itself. So if we go back to the NF Core website and we go to the repo, so this schema file, Nextflow schema JSON, is something that we created in the NF Core community to standardize how we define parameters in pipelines. And this has become really important for us to 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 make these pipelines runnable via user interfaces as well, because we've got a computer readable form now that defines all of the different parameters that I can run this pipeline with. So not only can we do other cool stuff like parameter validation, name validation, automatic help text generation, and that sort of stuff, what we can also do now is, rather than typically just running this pipeline by the command line, we can render this form in a user interface like we're doing here on Tower, to make it easier for users to configure which options they'd like to use when they run this particular version of the pipeline. And we've written some blogs. Maybe Rob, you can put them in the Slack for best practices around developing this schema. On the NF Core front as well, we've written a blog on the Secura side to make it a lot easier to do that. Hopefully that answers your question.
Great. Next question, I think a quick one. Is it possible to resume a failed pipeline from another team member?
Yes.
Good question.
Yeah. No, the answer is yes. Yeah.
So you can.
Maybe I can cancel. Oh, my one's finished.
Presumably, if you're in the same workspace.
Yeah, you should be able to.
Yeah.
I don't know why this one failed. Why did this one fail?
And from Camilla, is there a way to script to wait until the pipeline will be finished?
Yes. So if we look at the TW CLI and you do, it depends what exactly you mean there. But if you look at the TW CLI, which presumably is what you mean by script, when you do TW launch, there's a wait option here. So what you can do is, when you launch the pipeline, you can wait for a particular status when the pipeline completes, if you want to automate this behavior. But you can also use API calls and that sort of thing to poll periodically, say, for example, rather than waiting, just to poll periodically to see whether a particular pipeline status hits a certain value. And then based on that, you can do the next downstream steps.
Looks like you nailed that one. Saw a response from Camille. Is there a dashboard support for work done in Nextflow Tower with NF Core pipelines? And does the dashboard have to fall into the NF Core dev side? Dashboard with metrics from different parts of the pipeline, like bow tie to output, etc.
Dashboard depends what you mean by dashboard. So, so at the resource level, there are already metrics here that I didn't really show you at the end, because I showed you up until here. But these resource level, there is a summarization, and this is sort of pipeline agnostic. It doesn't have to be NF Core. It can be any Nextflow pipeline. It shows you all of the different metrics that you've obtained when you ran this particular pipelines in terms of CPUs, memory, and task execution real time. And in fact, some of this is what we use for that optimization feature, because we're collecting these metrics in the task table in terms of what you eventually use. We can then optimize with machine learning to predict what you should be using. In terms of outputs, there will be, as I mentioned, our first iteration of a data explorer that allows you to maybe browse the bucket. So now that when I created this compute environment, for example, I defined in here a work directory. Now, this work directory is some storage that I've got in the cloud that this compute environment has access to, because I've given it permissions to access to. Now that we've got credentials in this workspace, you can imagine just there being another Data Explorer tab here that allows you to hook into those credentials and browse the buckets directly within Tower. So that's the first version of that is going to be coming out. We're testing it now, and it should be available soon. I'm not sure whether that is what you meant by metrics, but hopefully that. If not, we can follow up.
Okay, what's the best way to go about setting up a large custom database in an S3 bucket? It's a challenging one.
It depends how you mean and how you want to run your pipeline. So typically, using protein folding pipelines as an example, they have massive databases, like terabytes of size, and I'm not sure whether you mean in the traditional sense, like a MySQL type database, or just a standard sort of genomic reference sequence type database that you might have with protein folding pipelines. But in the latter case, Fusion is actually going quite far in helping to solve the issues with getting these data and staging them to run with pipelines, especially in cloud environments, because you're essentially in a way mounting buckets into the containers where you run the tasks in the cloud. What that means is you're not moving terabytes of data from A to B before you can run that process. And so we've been playing around with Protein Fold, for example, in Fusion, and just having a simple your database in an S3 location somewhere, then that makes it a lot easier to stage that data in, do whatever computation you need, and then publish the data out and go to the next steps. And so, yeah, I would definitely recommend having a look at Fusion in that case. It makes it much more efficient when you're dealing with big files like this.
Great. Next question is from a very familiar name. Which parts of Tower are free and what is paid for? So I think I'll take that one myself. So if you go to our Tower website, you can see the pricing tiers there. There is a free tier available. It's fully functional in every way. What you don't get is commercial support, and you're somewhat limited as to how many users. There we go. You can see it on screen there. If you just scroll down a little bit more, you can see the quota limitations on the free tier. So there's limitations on the number of users. It's 5, and there's 3 concurrent runs that you can do. So if you want to run massive workloads, you're not going to be able to do that. And there's a 250 run history. So it's great for trying things out, great for testing, maybe very, very limited production use. And then you can contact us to the right-hand side to talk about, if you need more scale, you need more support, you need, more than 3 concurrent runs, et cetera. We're happy to engage with you. So hopefully that answers that question. Let's see what else we have here. Do you need to do anything special to allow Wave and Fusion apart from using AWS?
It depends on your infrastructure. So this is, I guess, one of the strengths of Nextflow and Tower is from conception, they've been designed to work pretty much anywhere. But that can also be a problem because we want to get Nextflow and Tower up and running on all of these diverse environments that our customers need to support. Now, depending on how locked down your environment is and how firewalled it is, those requirements will be completely different. And so for some, it will be, a couple of hours installing and getting everything running. For others, it might be more of a process. So it will depend entirely on what your infrastructure looks like. But in theory, no, other than maybe adding Docker credentials as well, like I did here to use Wave and Fusion in our demo workspace right at the beginning. So Docker credentials, that's mainly to overcome the issues that Docker recently throttled how you can use their APIs for free tiers. So you need to log in and do it that way to get a higher tier of usage. But that's basically it. You don't need to do anything else special. If you use Tower Forge or Batch Forge, which is automatically creating the head queue and the compute queue for you in your compute environment, which is what I've done on this demo, then all of those permissions and everything that you need to add is automatically pushed and created for you. You don't even need to worry about any of that because these are updated as we update Tower.
Excellent. Thanks, Harshal and Rob, for the Q&A. There's a few questions left outstanding. We're going to get to you folks via email to address those because we are running out of time, but we appreciate all the engagement. We appreciate you attending. It was actually a lot of fun.